Hello, everybody. I'm Helen Whedon, the Managing Director of the Satcoms Innovation Group. And today we're going to delve into 5G and spectrum. And in a few moments, I'm going to hand over to Andreas Vogt from Eutelsat. So Andreas has more than 30 years of experience in satellite communications across different companies, including the German Research Center Institute Fraunhofer. And he currently is working as the Global Communications Systems Manager and Head of L3 Support in Service Operations at Eutelsat. While fast-moving in problem management, he fosters first and second level control center engineers worldwide with knowledge transfer, tailored training programs and continuous technical advice. And we certainly within SIG as well as at Eutelsat draw on him for as a technical reference in service operations because of his deep technical understanding and ability to find solutions in very challenging environments. So who better than to lead this discussion today? And I will turn over to Andreas now.
Thank you, Helen, for this nice introduction of myself, and would like to introduce now in our panel discussion 5G threat or opportunity for Satcom and for the mobile phone industry and environment, and would like to introduce my panel now today, which has 4 members. Would like to welcome Alexis Theodotou from Avanti, working as Regulatory and Space Development Manager. Good morning, Alexis.
Good morning, everybody. Thank you for having me in this panel discussion.
Yeah, no problem at all. Alexis is a Regulatory and Space Development Manager at Avanti Telecommunications, with more than 17 years of in-depth experience in satellite systems and applications. He's responsible for the frequency coordination team of Avanti, spectrum resources and satellite network filings, leading the coordination discussions with other satellite operators and administrations. This role requires, among others, extensive knowledge and understanding of the ITU radio regulations, negotiation and technical engineering skills related to satellite communications. My next panel member is Bo Backus from the Johns Hopkins Applied Physics Laboratory. Good morning to you.
Good morning, Alexis, and very happy to be here. Thank you very much for inviting me to this panel.
Bo is an experienced senior manager with a demonstrated history of working in the defense and space industry. He is skilled in management, spectrum management, total quality management, and space operations. Strong professional with Master of Science, focused in technical management from Johns Hopkins Writing School of Engineering. At the Johns Hopkins University Applied Physics Laboratory, he is representing the National Oceanic and Atmospheric Administration, National Environmental Satellite Data and Information Service, NESTIS, from spectrum management to project management under an Interpersonal Act contract. So, welcome, Bo, to this panel.
Thank you.
Our next member is Martin Coleman, board member of the Satellite Innovation Group. Hello, Martin.
Thank you, Andreas. It's good to be here, and I'm looking forward to this panel.
Martin was Executive Director of the Satcoms Innovation Group until December 2019, and is now part of SIG's advisory board. Since 2011 as IRG, he has been active in spearheading several significant initiatives, leading the advance in new tools to resolve all types of VSAT interference, including SATGuard, and introducing Carrier ID. Martin regularly addresses the industry on management of spectrum and space, including radio frequency interference, at global industry events and facilitates SIG workshops throughout the year. Martin also specializes in network management, communication projects, event management, workshops, and we all need to congratulate him for his 50 years anniversary in the satellite communication business. Congratulations, Martin.
Thank you, Andreas, and thank you, everyone. You know, still counting. Just remember that, still counting.
Having not said anything against that, Martin. Wonderful that you are here. Our next panelist is Yoshinobu Ogawa, who is working as a technical satellite consultant. Konnichiwa, Yoshi.
Bonjour, Andreas, and thank you for having me on this panel. Really looking forward to discussing all the interesting issues that are going on in the industry.
Thank you, Yoshi. Yoshi has been devoting himself to the satellite industry for more than 20 years. His career started as a satellite manufacturer, then became a satellite operator for 3 different countries over the following years. He has been accumulating his knowledge and experience by working in the broadcast and communication sector. So welcome, Yoshi. So now it's time to give a short introduction into the topic what we are discussing here. So from my point of view, 5G has been the topic of the year in terms of global network convolution and satellite communication impact. We have seen companies going, we have seen companies coming, and we have also seen loads of new environments from LEO initiatives coming up with 5G even from the sky, using the capabilities of the 5G protocols and the levels of modification and options inside the specification of that versatile, usable network protocol in the environment. So that means very clearly we have here something got to do, which is also going to be merging with satellite communication interests. But when having a look at satellite communication interests, it is very clear as well that we must not leave out the environment where existing satellite communication services are actually interrupted, disturbed, or degraded in such a way that customers might not use their traditional frequencies anymore. And here we need to think about the C-band alliance, what has been working on for the protection in the environment and changeover for the arrival of 5G, and which is now coming to an end with the decision making of the FCC in the short future. But we also need to think about that things like broadcasting capabilities of 5G and the so-called NTN announcements which have been done, so the non-terrestrial network which 5G is going to have in the future, they are going to be very clearly in use. Frequency reuse is going to be done partially between GEO, LEO, and terrestrial networks, also using the 5G standard. And the question at the end, for sure, is if technology like DVB would then be, at the end, maybe even a success by 5G broadcasting environments. So I would like to start with this discussion. And ask Alexis, who has prepared a presentation for us, to go ahead and take his view of the action.
Thank you, Andreas. First, thank you for giving me this opportunity to be part of this panel discussion. And if you allow me, I can just approach this topic on a more controversial way. So satellites are an integral and effective part of 5G. 5G is not just about terrestrial mobile networks, but it's also a network of networks that pulls the strengths of different technologies. Satellites have unique characteristics and capabilities that will allow and extend the reach of 5G networks and enable to host of 5G services. Satellites have the ability to provide services to wide area coverages that is vital to extend 5G networks to low density populated areas, including communications on the move in sea, air, and land. They have capabilities for one-to-many distribution, such as high capacity backhauling connectivity, and can offer reliable and resilient operations. In order for both these technologies, terrestrial and satellite, to deliver their services reliably with high quality of service, they need to have exclusive spectrum allocations and assignments so that to work without causing harmful interference between them. Sharing of spectrum in its true sense, meaning co-frequency, co-coverage, and co-temporal utilization, operations between terrestrial and mobile and satellite services is not possible. An example demonstrating this, it's, Helen, if you just go to the next slide, please. Yeah, it's a sharing study between 5G INT and the impact on satellite receiver stations. This study was carried out based on approach taken by the Europe EC framework on the impact on new deployed 5G base stations in the areas or territories where satellite have been operating for many years. And the study will show the frequency, co-coverage, and contemporary operations between these two systems. So basically, in order for the satellite to keep working in an interfere basis, there must be an exclusion zone protection from the deployment of 5G. The study showed also that protection criteria based on maximum permitted field strengths in the input of the received satellite antenna or maximum allowed transmission density for the 5G stations must be in place to protect the existing operations. Also, not necessarily in the overlapping bands, but also in the LNA and LNB operational range, there must be also protection from the overload effect of the LNA and LNB receptions. Furthermore, in the nearby adjacent bands, there must be also out-of-band protection criteria that need to be put in place, and also mitigation measures for the 5G deployments, such as sector blanking, down tilt, and the restrictions on the height of the base station, antenna base station, must be also put in place in addition to the exclusion and zone and power restrictions. And then to conclude, is that regulators, in the last slide, must take a balanced approach to spectrum allocation and use, so that these technologies have their unique spectrum assignments for operating without causing harmful interference between them. In the latest World Radio Communications Conference that took place ending last year, WRC-19 has identified a huge amounts of spectrum for 5G on a primary basis, a total of 17.25 gigahertz of additional spectrum for INT. In the frequencies in the bands in the KA, Q, and V bands for the deployment of 5G terrestrial networks. It's evident thus that there is plenty of spectrum for terrestrial mobile networks to expand and for policymakers to assign this spectrum for INT before additional spectrum is allocated. Satellite and terrestrial mobile are complementary to each other, and the vision of 5G cannot be delivered without both these technologies operated uninterrupted in an interference-free environment, ensuring that the benefits of 5G are accessible to everyone, anywhere. And yes, that's my approach, and thank you.
Thank you very much, Alexis. That has been very clear what you have been saying in this environment. And let me have one question here, please, with regards to regulation in terms of the 5G rollout and environment, what might be necessary in satellite communication environment. So you have said very clearly 5G and satellite communication in coexistence, when especially using the 3,400 to 3,800 megahertz band, is not really something which is nice to have. It might not work. We might have interferences in the reception sites, and it is local. So it depends very much where you are going to have the interferences. If you have the antenna behind the building, then maybe you are not affected, but 10 meters further, when the antenna has the free side towards the 5G transmitter, you cannot use this frequency bands. How shall we tackle that? Because I would see some necessity in the regulatory base that certain direct-to-home or VSAT type C-band environment, especially when having a look at Southeast Asia, where C-band is the necessary communication environment which you need to have, because due to the heavy rains we have in the tropics around Indonesia, Malaysia, and Singapore, for example, we are not really getting through well enough with the availability numbers. So how do you see that? How can we do that to protect satellite communication interests and 5G, even national regulated interests of build-ups of the network? What's your idea?
Yeah, so when it's inevitable that the spectrum will be auctioned for 5G deployments in many countries, and some already have assigned the spectrum for 5G. So in the auction process, there must be clear protection criteria around at least the existing C-band operations, receive operations, and there must be ways also to protect these operations in terms on a combination of parameters like exclusion zones or protection criteria based on transmission densities, or both, and also ways that the 5G installations based on the height of the towers that they're going to be deployed in sector blanking and downtilt as well, will be helping and actually preventing interferences towards the existing air station receivers.
Okay, perfect. So now let's have a look a little bit further, medium to long term. What do you think? We have seen in your presentation very clearly also frequencies in Q and V band, and maybe even in W band. So where are we going here? Are we going to have certain environments also, let me say it like this, polluted with terrestrial environment 5G for things that we are thinking about to use for higher bandwidths in satellite communication environments? How shall we do it there? How shall we assign and build up our future networks, especially with regards to the interests which Avanti has and which Eutelsat has and many other satellite operators have as well in the VHTS satellite industry? How shall we go?
Yes, indeed. So we are now in the era of the high throughput satellites, and very soon to the very high throughput satellites. So the need from spectrum in higher bands is vital to expansion of the geostationary, also in the non-GSO networks for expanding our services. So based on the conclusions of WRC-19 and the allocations to spectrum, there has been a clear large and huge amounts of spectrum that has been allocated for terrestrial IMT in those Q, V, and W bands, which will be used as a primarily for IMT operations. So I believe that there is sufficient spectrum which is allocated to those services for expanding and assigning spectrum in those bands, and keeping separated the bands that there are already allocated for satellite communications, so that both systems can work uninterrupted, basically.
Thank you, Alexis. That was very clear, and also from the regulatory perspective, which is one of your strengths and fields of work in this environment, very valuable input to have this analysis here in 5G threats or opportunities. Now let's move on to our next speaker, Bo Backus from the Johns Hopkins Applied Physics Laboratory. We're all excited to hear about your points of view with regards to our topic.
Thank you very much, Andreas. And Alexis was a fantastic speaker for getting across some of the spectrum issues that we're faced with the implementation of 5G. There's a lot of value in this spectrum. And one of the things that we spoke a lot about at the World Radio Conference was how to use the spectrum without putting the incumbents at risk and degrading the ability of other systems to operate as they have operated. A major system or major use of spectrum that's very close in frequency to the 25 gigahertz band is called microwave sounding. And this is a use by which meteorologists, climatologists and such collect information all around the world on exactly how much moisture is in the air and a variety of other types of sensor data that they pull in with overhead satellites. This is really a challenge because one of the aspects that is often overlooked in spectrum management or in the use of spectrum is the fact that you really don't stop using the spectrum right at the edge of which you are allowed to use it. If you're given a band at 24.25 gigahertz up to about 27 gigahertz, you really have energy that flows a little bit below and a little bit above. It slopes off. And that is where we have problems. Years ago, we would actually create something called guard bands around these slopes. And these guard bands were an ability to keep different users apart from each other. The current day value of spectrum has made that really, in some places, a bad word. If you started saying guard bands, they would say, get out of here. So we really have to be even better about how we put different systems up close to each other. The challenge with passive bands is that the satellite is actually looking at the thermal energy of the globe, of the Earth, and that thermal energy is going through the atmosphere. The differences in the atmosphere is the information that they're seeking. So any additional energy that comes into that particular frequency or band is actually undistinguishable from that of the Earth. It's all noise. It's just that we have kind of a concept here of good noise and bad noise, or natural noise and man-made noise. And we really are challenged here with how much of this man-made energy now will become part of the collection, and how will it skew the results of our meteorologists. Initial looks said, and analysis have said that it will affect us. When we started looking at exactly how much energy would be added into it and how much density and how prolific 5G will be around the world, we started to see that there is a chance that this could be a problem, a very serious one. The discussions were long and heated about this, and we're very much trying to find ways in which we can keep as much of the man-made energy out of the passive bands as possible. So there's a lot of concern about what is exactly going to happen, and a lot of good people are looking into possible ways that we can move forward where the use of the 25 the 24.25, 27 gigahertz bands will be done without at the cost of degradation to our forecasting. And as you've seen this year with the number of hurricanes and such, we're very concerned about making sure that we have the best measurements and capabilities possible for everybody on the planet. So I think 5G is got a lot of incredible potential, and it's extremely valuable capability for our world, and looking forward to everything it can do. But the challenge here is to be able to do so in a way that minimizes, if not completely mitigates, the risk that we will harm some of the important other activities that are taking place in and around these bands. Thank you, Andreas.
Yeah, thank you, Bo. That has been for sure very, very nice, and a little bit of a different flavor than what we know actually as satellite communication environment here for that thing. But we must believe very much into the point that 5G can produce interference, and not only to the satellite communication links, which we are looking into it on an everyday basis in our service operations, but it might affect also many other things. And I would like to underline here maybe a little bit the vulnerability of certain environments, because you are measuring in the 25 gigahertz range the necessary meteorological environments, maybe also with instruments from low Earth orbit satellites or GEOs or from ground, wherever you need it, wherever you want to put it, and wherever you see also in your research environment an advantage where to put the new technology and get better and more predictable solutions for the next days, and warn people for loss of life, loss of property, loss of things, and be there as our all beloved watchdog to make it very much clear in this environment to keep us safe and sane from the adverse effects that we are all having, especially with regards to global warming and these kind of effects, which are undoubtedly here in this environment visible. And the number of hurricanes has been growing up pretty substantially over the last 20 years in comparison to the times before. So we shouldn't ignore that point. Absolutely clear. So now we need to find, and that's why we have this panel of threat and opportunities for 5G. We need to find a solution. We need to find something where we would like to go for it, because 5G is a fact and 6G is under development, maybe with even more necessities for taking frequencies. It is also a fact that we have your measurement environments, our C-band satellite environments, our needs in 28 gigahertz to have uplink connectivity in Ka-band from ground to satellite. This all doesn't need to be, and must not be actually, interfered with new terrestrial services that would like to have these kind of frequencies just taken up. So how can we make it possible that both of the environments can actually survive? Give us a clue, Bo.
It is a challenge right now to be able to do this. If we had an easy answer, great people like all of us would not be in the middle of trying to solve it. There is not an easy answer on this. This most straightforward one from before was simply to say that we avoided operating directly adjacent to very quiet, very sensitive bands. It's that would be the most quick and easiest answer to occur, but we just can't do that. There's too much demand and too much need for communications in this world than there ever has been before. in some ways, you think of passiveband as being this great port that ships can come into and dock and operate well. That's a nice open port, but we need more land, so we start filling in this port and adding more dirt and adding more dirt, and so the ships are having to squeeze in just a little bit tinier and tinier each time. And so in this case, we're looking at having a challenge on how do we maintain the value of the microwave sounding? Can we find an alternate to it? Are questions that have been raised that we'd like to investigate as to, are there some techniques, GPS radio occultation, for example, can that be an alternate to microwave sounding? Some of the meteorological experts say that there are significant differences between the two, and that really isn't a clean way to try to find an alternate answer. One of the beauties of microwave sounding is it does not depend on having a clear view of the Earth. Clouds and so forth are not affecting the measurements. So the answer to how we could share is things that involve being very sensitive to each other's requirements. So, for example, there might be a higher expense with adding more filters to the out-of-band noise that is generated. That helps a little bit. Keeping the power to the absolute minimum needed also will help. So there are steps that can be taken, but each of these steps do cost money, and they do help. We're also looking at trying to focus a lot of our measurements in the ocean, where hopefully we won't see 5G for a little while. But I would like to say that all of these steps each one has a certain amount of cost, and they have a certain amount of challenge to them in being able to implement them on a worldwide basis. It takes a lot of cooperation from all of the providers and users around the world, because this is a global activity, and we're not used to a lot of that. In the satellite world, we're used to global activities, but now this is a global activity in 5G. So we have to work together.
Yes, absolutely. And here, from my point of view, as Alexis has also come up with, and me in the intro a little bit before, we are going to see some convergence between the 5G and the satellite communication environment and all of the other communication necessities in this environment. So I think without sitting together on a round table or whatever, we are not going to have the threats or opportunities very well defined. Means we can see it positively, we can see it negatively for one or the other, and at the end we might end up in a little poker game where we have to see who has the better cards and who is the better negotiator at the end. So going away from the technical environment, it is also very clear that this game is going to be in the outcome a financial environment also for the licenses of 5G, because that is going directly into the country regulatory tax department, whatever is going to be paid for the licenses in every country, and that shouldn't be so unforgotten about it. We see that very clearly. I guess our next panelist has also something to say in directly this direction. Martin, I'm really looking forward to have a look what you are going to tell us all about. What do you think? Is 5G really that much of a threat to the satellite communication, or are we going to have a good opportunity for collaboration in the future? Tell us more about it, please.
Thank you, Andreas. Well, thank you, Alexis and Bo. What a great start. What two different areas, two different thoughts, putting the basics down. Here we go. So, what do I think? Well, I won't, because we're live. I'm not going to pull the drain lids up on Spectrum and throw them away. I'll just peer down the drain and see what we can see for a minute. Otherwise, we do live in a rather techie world, and I'm sure that if we threw the drain lids away in too much of a hurry, then that might cause a little stir. We don't quite want that, but we need to start solving the problem. And in SIG, and as we were as IRG, we've actually tackled, can we share C-band, for instance? You know, can we do it? Well, the answer is sort of, but it's tricky. And there are three main areas, and you've all come up with them so far, Alexis and Bo. But one question that's up there, because we're it's the whole thing about spectrum, it's manually allocated. And there is inherently a problem in that. It's got to be dynamic. So let's move on to that, because think about the spectrum we use now. Do we know what is actually used and when? How many gaps are there? We keep getting allocated all this and we say we need it, but do we actually know how much of it's actually used? There would be an interesting thought. Maybe we don't need so much. Oh dear, the drain lid's come up a little further. Must put it back down again. And it's the same for 5G, 4G, and any other G we can come up with. Do they use everything they need? And we need to be a little smarter about this. And I know, and I was looking at the DoD example of sharing 2 gigs in the US. It's a great example of how to manually, through coordination and various processes, to manage a piece of spectrum that is basically used by 2 people and cannot be shared. But it can. It has to be managed. It's very manual, but it is a problem, but it can be resolved. Then, of course, there's technology, signal cancellation, filtering, etc. Better management, there's a thought. You know, if we had a dynamic, smart super network, it's probably the only way forward, and it is probably the smart way forward. You know, wouldn't it be useful to know what we did use and when? All of us. Let's not put the barrier about satellite in here. I'm talking about spectrum. Let's think about this. If we were in charge of the ITU, do we know what we're using out there? This, before we get into the WRC merry-go-round, does anybody really know what they use? There would be an interesting thought. Data is king. It's key to everything. If we know the answer, we might be able to find the solutions. But actually, we're not that clever. We don't know the basic problem. And there is inherently the problem that our dear Alexis and others have to go to the ITU, and once every 4 years or so, we go through this huge merry-go-round of trying to solve. It's crazy. It's time that stopped. For one, technology and our users want things to happen now. 4 years is too long. Also, we know that certain parts of the spectrum, Bo, you just earmarked a piece of spectrum that's probably necessary. Let's not worry about whether we could do it differently or money. Let's go for that's necessary. Disaster recovery, global health needs. Well, you know, there you go. We know what that's like right now. Yes, some frequencies will have to be allocated and kept for safety. We need them. But, you know, there's probably plenty to go around. It's just we don't manage it well enough. I would like to say stronger than that, but we'll just go for not well enough. As I said, I think it's crazy. I think the 4-year rolling process of WRC is totally wrong. We must be more dynamic. We must now use the newer technology to do this. And this is where I'm talking about smart, software definition, artificial intelligence and machine learning. If you put all that together with decent data input about what we do and don't use, then things can be shared on a totally automated basis, both terrestrially and in space. And that is probably how we're going to have to do it. The problem is, the crazy thing is, we actually know all this. This is technology that is here today. This is not a surprise. So why are we not, as an industry, or industries, let's say, getting together, like Bo said, we need to do this together. It can't be done individually. We need to do it together and make it happen, because we know how, we've got the tools, they're there. We just don't know the data, and we're not smart enough to really manage our way out of this paper bag at the moment, and we need to do better. So there you are, Andreas. That's what I see.
Thank you, Martin, for keeping it quite short and detailed in your high-quality way of thinking and the high expertise you have. Always a pleasure to hear you talking about this. Let me say one particular thing. When using, and you mentioned it very clearly, machine learning and artificial intelligence, that is based on a lot of data which we are actually taking up and need for calculus and correlation and find solutions and so on. So at every environment of artificial intelligence and machine learning, you need to have a certain amount of data which is valuable to put into processes. So this data collection needs to have started several years ago, if we would like to take it now up to the point of integrating and finding new AI solutions in this environment, and to hinder that. How can the industry do better in the future, maybe in the integration of new frequency ranges, 6G and whatever? What do we need to start right now? Tell us from your view, please.
Well, it's like us, Andreas, trying to solve interference. It's like us. We have to collect data to figure out what it is we have to solve. If you don't have any data, you're going to go in the wrong direction. You could even argue carrier ID at the time was possibly the wrong direction, but we had a hold because it meant something about interference and SNGs. But in the end, it was the VSAT problem that had to be tackled, and we tackled it. And ironically, carrier ID led to the solution that we have called SatGuard and other things out there. But you see what I mean? That we needed data to really tell us what the real problem was. And we knew what the real problem was. Sometimes you have to go around a little bit of a loop. But we're at a point now that we need to speed up. And I can only hope that Bo and Alexis can go back to the ITU and start kicking them a little, saying they are the key to this. You have terrestrial one side, satellite the other. Well, that's got to stop. We have to do this together. We probably, let's just take Eutelsat as an example. There's probably enough data in Eutelsat to say how much of the spectrum you used and when you used it. It would be interesting to analyze just that fact for one operator about the whole bandwidth they had. And over the last 10 years, I know you have data there that could probably tell us the answer to that. So if we did that for every satellite operator, that would start to give, might not be the best picture, but it would give a picture. It would statistically get us closer to what is possible, of what we can share, what we can't share, and everything else, and all of the above. And I am darn sure that the terrestrial people have those same records still. But someone, and we're back to money, Bo, you said it, money. Someone's got to put money on the table to make it happen. Ironically, the mobile operators are the rich guys. They still need the satellite to make it operate. This is madness, all this battle going on. This war we've created over spectrum. We need to be grown-ups here. I'm not entirely sure the world is that grown up at the moment, but never mind. You know, we see history repeating itself. Look at the counter at the top there, 50 years. Seen one or two myself. The point is, we have to do this together, and the quicker the satellite boffins get together with the terrestrial boffins, that will be the greatest move to solve this problem. Engineers are good at solving things, but you've got to tell them what the problem is. And we need to define the problem. You know this answer, Andreas. You could have answered this question yourself. That data, whatever it is needed and needed now. It's there. I'm sure it's there, hidden away, but it's there.
Yes, and we should actually do also from our side, a little bit more homework, let me say it like this, and try to gather even a bit more data into the direction that it becomes useful for our own processes of spectrum optimization, usage, and better financial outcome at the end. It is also very clear that certain frequency areas which are primary assigned or secondary assigned, and then if it is secondary assigned, sometimes we have not really a lot of activity there. So for example, for the super extended C-band in the 4.4 and 4.6 gigahertz downlink region, we have certain satellites who are operating in this frequency, and they are absolutely interference protected from anything what 5G in the lower frequencies in C-band are going to use, because the L-band environment and the LMBs are not getting that energy from that frequency range, as different filters, as Bo has said very well, are integrated in this kind of things. So this is what we need to have a look at as well, and just be a little bit more clever. And talking about clever people, I think now it is time that we are going to have the words from our last panelist, Yoshi, who is also representing with high value our folks in Asia, and especially Southeast Asia, where C-band is one of the most necessary and technically important environments. So let's hear what Yoshi has to tell us about threats and opportunities in 5G.
Thanks, Andreas, for calling me clever, which I am not clever, but I do have some insights as the representative of Asian or Southeast Asian resident. I have two aspects to look at 5G. One is negative, of course, and the other is positive. I'm going to start negative because it's always better to go up in the second half and then going down in the second half. Negative part is that 5G is leveraging two frequency bands, which is C-band and also the Ka band. Both frequency bands overlap with geostationary satellite communication, and especially in the C-band area, Southeast Asia just needs it for satellite communication, especially in the geostationary area, since we have a lot of rain, and a lot. Even in Japan now, since the global climate change, we are experiencing a lot of concentrated rain, even in Japan. And some of that rain even interferes with C-band, which is known to be robust against rain attenuation. However, that's not the case. Some rain would be blocking even C-band frequency communications. And also, not only overlapping to the frequency on the ground, as Alexis was mentioning, interference into the ground station, but I've seen coincidentally, a very interesting situation where we are using S-band and WiMAX, and there was another satellite phone service that was using an S-band frequency band, and we could see the WiMAX noise floor going up in that area, which was only used in the ground terminals. So when the ground terminals are emitting very small power, it doesn't have any problem. But when that power accumulates, as Bo mentioned, it becomes a noise floor that is not something that we can ignore anymore. So, and 5G for sure would be millions and billions of terminals using the same frequency band. So as Bo mentioned, we need to stipulate a certain guard band or a safe guard band in order to avoid communication confusion between the two networks. And also, I would like to say that when you talk about global climate change, for example, LoRa, if you see the aftermath of LoRa, there will be no way people will be able to communicate in a very sufficient way with only terrestrial networks. Satellite communication, especially the geostationary ones, would be a must. When you take an example in 2011, Japan Great Earthquake, satellite communication was the core network that was contributing to the relief program. So satellite communication is a must, and that's the negative area where I would like to take as a 5G deployment, because it will not be coexisting as Alexis mentioned. It's not going to coexist, but we need to somehow coexist in a very good way. And as Martin said, maybe it's time for a smart frequency allocation system is needed. On the positive side, I do understand that the frequency spectrum is limited. It's not infinite. And we need to share, and data demands are really climbing in a huge surge since the smartphone deployment. So 5G deployment is a must, but as Bo mentioned that we need to be talking between the engineers how to coexist or I would say coexist in how to reuse the frequency resource, and also to reuse the geolocation as well. So that's one way we can take it. And I think that's pretty much it from my side.
All right. Thank you, Yoshi. Just coming back to Southeast Asia and having a look at the countries around the equator where C-band communication is really necessary, but also at the same time broadband communication for the public and for schools, for the industry is also necessary. And as people there do not really have fiber into the small villages rather than copper, everything is more or less going either via satellite or via direct signaling. And then we have 5G coming and taking out half of the frequency band. How are we going to make it work in this environment that development of Southeast Asia is not going to stop because people are going to be cut off from the data delivery environment as the satellite communication links, especially for Ring of Fire, disaster recovery, and so on, is needed in satellite communication as nothing else. Into it, SATCOM-based VSAT stations serving ATM machines, enterprise resource planning of plantages everywhere towards oil rigs, either in the sea or on land, geo measurements on volcanoes, tsunami buoys, and so on. So all of that is meant to be a go via satellite, and for sure 5G, when partially using these things, might even block out the reception of these signals in the environment. How shall we do it at the end? Where are the proficiencies? What is your outlook? Where shall we go? Shall we abandon C-band as Thailand has been suggesting and making decisions out of that, and go to higher frequencies, which might be then a victim of 6, 7, 8G developments in the future, eating up more space, which satellite communications has been doing and using. If we let them go right now with C-band, maybe they learned their lesson and will try with Ku-band later on. What's your idea here?
So, as mentioned, C-band is a must in the Southeast Asian region. And once you abandon your rights, it will be very, very difficult to win it back. And once the systems are deployed, it will be nearly impossible to go back. So from my perspective, I would never abandon, but I'm just an individual, so that maybe the world trend will move into a different way. But luckily that the 3GPP that is discussing the 5G standard is including the satellite communication into the 5G standard, which I am a little bit relieved to hear, because that means that they need to discuss and find a way to have a satellite and terrestrial friendly way of operating the 5G network. So that part is good. But also, as mentioned, abandoning one frequency, right, would be, I would say, not a competent way to do it, because once you abandon one thing and then everybody else is swarming on the rights, then you'll never be able to win it back, which you realize later on it was something that you really needed in your system or in your business, or not only in the business area, but as a humanity, because in Japan, satellite communication is I would say mandatory for disaster recovery, relief programs, and that's going to happen more and more as the climate changes in the globe, because I see a lot of natural disasters more and more every year, not only in Japan, but not a lot in the US, for example. A lot of hurricanes are attacking, and that's something that we should not let go that easily. So yeah, that's my perspective. And the ultimate, I don't have a silver bullet to solve the whole problem, but the key to keep the environment clean is communication between all the entities, all the operators that are operating in the frequency spectrum, to communicate with each other and to share the problems, share the use cases, share solutions as well. I understand that on a benefit point of view, financial point of view, or business competitor point of view, you need to hide some information from your competitors and rivals. But as an operation guy, I would say that sharing some data that you can, as much as possible, sharing, and as Martin mentioned, data is everything. And sharing data with the necessary people would be the I would say the silver bullet to solve all these interference problems.
Thank you, Yoshi. Very clear, and out of the perspective of somebody living in the area where we are having the most effect going to be foreseen, that's a very wonderful and very useful word which you have spoken and participated here. Would like now to go back to all of you in the panel and speak about something which might be in the medium to long-term view of the 5G environment. Because as you know, satellite communications, and especially the GEOs and the delivery via HTS or standard satellites, it's all going to be more or less the identical thing. Satellite has a very high potential and business case and will always have for broadcasting content. So that means you need one uplink and you can serve all Asia, all Europe, all CONUS, all the Americas in one go. No matter what kind of frequency you are using, the broadcast capability is undoubtedly one of the highest goods of the geostationary satellites. Now, having a look in the environment of 5G broadcast, what do you think is going to happen with that kind of thing? Are we going to have here a harmonization in the mid to long term as well? Are we going to have, for example, a changeover from DVB technology into 5G broadcasts? Because these kind of things here, they are not going to have a DVB chip inside, but I can see television sets at home having a 5G card and 5G capabilities of reception very much available. So, to all of you, who would like to answer first? What do you think about 5G broadcast capabilities and the capability of fostering 5G broadcast transmitters via satellite communication to have a business case as we do it today with terrestrial DVB transmissions. What do you think? Who wants to go first?
Okay, all right, thanks, Bo. I think it's bigger. We're back to this bigger problem. I think it's got to happen. That's what's going to. It's the 5G standard, shall we call it, that's going to take over from DVB as we know it. It's like the satellite industry hasn't. I know the 3GPP is happening and there's interest, but it doesn't really get into the part about getting 5G onto satellite as a standard. It sort of hovers around it, but it's not really there, not in terms of modulation schemes that have been needed. We've heard some of our colleagues in SIG from Kratos, for instance, of saying about the fact we need new modulation methods to do this, and they're the things that need to be developed. So there we go. That's something the old DVB people could get to grips with and start again. So but the other thing is we've got layers of satellite up there, GEO, MEO, and we will have LEO in whatever shape or form, but we will have one. One of those constellations will be up there. And if we get smart with the network management of everything, terrestrial to space, and all this frequency, we actually get smart about this, then all of the layers can do different jobs to then feed the 5G onwards puzzle. In other words, these layers, depending on latency or the lack of latency, whatever you want, we have the layers of communication to do it. And that's on the ground, as in fiber, right up through space. We've got layers of this stuff. It really is about the management now of this colossal network. We need to see it as one unique network, and people need to get their heads around that now and pretty darn fast. This is not about us and them. This is not a war. We got users who are going to spend the money. We still can't connect 4 billion people yet properly. And if we don't put this together properly, we still won't connect those 4 billion people. And if we go back to what Yoshi said about disasters and stuff, we need to connect all 7+ billion people on this planet. And we need to do it in a hurry. And it isn't just satellite, it is terrestrial and satellite. The whole thing is one unique communication system, and it has to be that way. Like it was 50 years ago. 50 years ago, satellite and terrestrial was one global communication medium. No barriers, common standards. And we've lost the plot in the middle. There we go. End of speech.
Okay, we have time for another comment of the panelists about 5G broadcast's future. Who would like to get into it?
Andreas, I've got just a very brief thing, 2 things that I think would be worthwhile to mention. One thing that Martin had mentioned is that there are certain aspects of the frequencies that are fixed by physics. When I was talking about the passive bands, for example, they are at the frequencies that they're at because of physics. So we have to think about our use of the electromagnetic spectrum in terms of what that gives us. There are certain frequencies, like what Yoshi had mentioned about C-band, that are important, especially in high rain environments, because when you go to the higher frequencies, it just doesn't work as well. And in fact, the amount of power required to get through rain at that level would not be good. So I think it's important to look at it from the fact that we have to fit within the world that we're given. A second little bit that I thought would be worthwhile pointing out is, as much as 5G is sort of being seen as the thing to discuss today, it was only about 12 years ago that the iPhone first appeared in the world. We're looking at 5G now, but that means we've gone through all the others. So in a very short period of time, we've stepped through a lot of things, a lot of technology, and to think that we're going to stop would not be good foresight. We have to look at this in the terms of the long-term game. We're in this to make things better, more technologically advanced. 6G is coming, and that's kind of that's what we see just around the corner. But what's further down the road? And we have to orientate ourselves now towards that growth. It's sort of like the old story of, you see your neighborhood growing. Do you start building the extra lane on the highway now, or do you wait until it's too late and you've got congestion? So hopefully we can actually start building this thing, seeing it and working fast to deal with not just 5G, but all of the technology wonders that are coming down the road. Thanks, Andreas.
All right, thank you, Bo. Now I would like to say it's time to wrap up our session. We have nearly taken all of the time available. So if I can just summarize from the input of all of my panelists and myself here, we do not really have at this moment for the short-term environment 100% available solution. If 5G is a threat or an opportunity, we're in between. We just need to have a look what the people who are running the companies and the interests would like to see as a threat and as an opportunity for their own personal business. However, this leads to, for sure, some sort of financial and technological war situation, which is not going to produce a winner on one or the other side. So that is why I would like to say it is time that we need to have a look into that and get into talks and your point, Martin, with the WRC, your point, Bo, with the meteorological environment, and Yoshi in site disaster recovery, as well as the one of Alexis with regards to the regulation necessities, what we have. All of this we need to put on the table, and all of that we need to find a solution with the most clever people of our industries together, and see how we are able to join forces and how we are able to make it possible that the size of our industry is actually big enough to compete with the environment of the companies that run 2, 3, 4, 5, 6, and whatever G in the future. So that means very clearly, even in the factor of being a junior environment here, there is a lot of necessity, even while it is only a small market share percentage in the environment. And we all know for data delivery, for HTS, spectrum is there, but the market in comparison, what the satellite can deliver is not as high as it is with the mobile phone or the fiber or the terrestrial industry. It's perfectly fine, but the market percentage exists. And it is a very important one, because if anything in terrestrial environment breaks down, satellite is the only one which is able to present the disaster relief operation. And that is the one also which is able to generate all of the necessities which airplanes have, which ships have on the oceans. And without satellite communication, no communication would be at all possible. Nothing will work without SATCOM in this environment. So that's why we are here in the SATCOM industry, a valuable player, and we can foster, and the 5G industry needs to understand and listen to us. What kind of threats are there for our way of communicating, and our customers who pay valuable money to reach certain broadcast aspects of our environment or the broadband delivery. So that is the point which we can make today, and that is the point where we have to start in the communications for today. Back to you, Helen. Thank you to my panelists, and a very good day to all of you. Bye-bye.
Thank you, Andreas.
Thank you.
Thanks. Thanks,
Thank you.
everyone.
Pleasure.
Light for the red light. Okay. Well, welcome everybody. So, can satellite and mobile coexist? What a question. Well, from my point of view, it must. There you go. I'm not going to say yes or no. It just must happen. That's my view. Now, for those that were listening to the previous panel, we really got into 5G spectrum, and these two panels do have some degree of overlap. And it's worth thinking about that spectrum often, it's supposed to bring us together, but often divides us perhaps here. And the panel we have here today, we're so blessed to have a very good view of the two sides. And I think, listening to my colleague a little earlier, these four people have really good views that we need to listen to, and soon. The panel's not long enough. I wish it was, because we could have a lovely discussion here. It needs pushing, because spectrum's one thing, but I'm more interested in getting the working together part together, a whole of this mess. And if you look at the background to me at the moment, yep, 50 years and counting. Okay, we'll stop the bragging about that. Where did I start? I started in a system that had satellite and cable. Let's keep it simple as that. And when I started, we had no differences about those two routes. They were not separate. They were seen as one communications service, one package. And I think, I have to say it again, I said it on the last panel, I think we've lost the plot a little. And we need to rejoin it. Because at the moment, people see the terrestrial side, the mobile side, as separate somehow to satellite, or satellite separate to mobile. There seems to be a bit of a gap. And we need to start filling the gap, and engineers could do this. I think it's an engineering problem that we face, and it's the management of how we do this. Yeah, all that wording, sharing, all of this stuff, managing how we do this is the key here, I think. So without further ado, Raphael, Alexander, are you ready to give us your intro, please?
Yes,
so I'm going to pass you over to our four guests here, because this is where the story continues. And I think we can come to some solid conclusions here that we can perhaps action after this and make a play, certainly in 2021, when perhaps all of us can meet face to face and do more. So I look forward to it. Thank you, everyone. Alexander, over to you.
Thank you, Martin. Thank you. Okay, short intro. I was working in the terrestrial telecom industry for several years, building the backbone networks here in Europe for Nortel networks, but involved also since more than 20 years in various satellite and SATCOM projects, also in support of wireless network backhauling and so on. So Martin, I think it's very clear satellite systems will play an important role in the coming 5th generation of mobile communication. The evolution of 5G into beyond 5G and 6G networks aims at responding to the increasing need of our society of the need to have various kind of transmissions in real time with a much higher data rate than we ever needed before. And so I think it is already common sense that this cannot be delivered purely by the terrestrial network. So in this framework, non-terrestrial networks will play a very crucial role. If these non-terrestrial networks will be satellite networks like we have them today, where we see the GEO satellites, but also the LEO satellites coming in, or if there is a shift also to pseudo satellites, like we say for high altitude platforms or PLIMs, that could provide a hotspot over a country, smaller countries or a larger city. That we have to see. But 3GPP, yeah, has started in the framework to address the inclusion of technology enablers in the new radio standard that was designed especially to allow an air interface to work between terrestrial and satellite networks. So from my experience and perspective, it will be very interesting to see how now the larger terrestrial telecom industry will work together with the satellite industry and satellite operators, or due to the need of completely different waveforms than we are using so far, there may be even a bit bigger shift, yeah, away from what we call today our classical VSAT networks using DVB, RCS standards, and so on. So what I see is that working together, providing needed overlays, not only in remote areas, can help to touch a complete new market, yeah, or to serve a market better. I found one example, and one example was that in the remote areas of the in South America, there's a dramatic shift already visible due to the usage of backhauling with satellites. But that maybe go even further, where we may have satellites that can provide even, let's say, flying BTS stations. Yeah, there are different companies with big plans, and one I think we have here on the panel. But that's it from my side. I think it will be hybrid networks. There will be overlays. We will have to see how these industries will match together and find the most efficient way to serve their end customers, especially because the end customers bring the money, and the end customers are at the moment more with the telecom operator. So that's it, yeah.
Thank you, Alexander. That's brilliant and a great setting. And it does remind me that I've often argued the case that, you know, a lot of people come up with this logging on a plane or something like that to some bespoke satellite service. And yet all the mobile operators have the billing and everything all in place. Why on earth we don't use them as the key to make everything else work on that on a package basis is right up there in there. So thank you, Alex. That's great. Now, Raphael, I mean, this probably draws you back to your Ericsson days. But of course, it didn't, as you said, you came over to the dark side of satellite. So what's your thinking from what Alex said, what I'm trying to think? Where do we go from here about the coexistence of the two?
Thank you, Martin. And yes, I think, you know, you just hit the nail on the head. So with the management problem, because as I mentioned earlier, so spending 20 years building the mobile networks and then leaving that career and moving into the satellite world, I just, you know, it was like a deja vu, like going 20 years back in time and like just trying to rediscover exactly the same challenges. And, you know, what struck me when I moved into the SATCOM world is that, you know, well, those methods are well proven and existing. And, you know, I kind of remember as well being there on the ground, building those mobile networks that was very often frustrated by the paperwork and the procedures and methods that were put in place. Because, you know, it was all well established. And, you know, I was like, okay, well, we need to be more agile. We need to be more responsive. And, you know, then you go, you know, moving into the satellite world, the first thing I found out, there is nothing almost really in place. We are kind of like walking blind very often. And it wasn't the problem of the engineering people, because engineers, you know, they sit long hours, sit 24/7, and, you know, they solve the problem at the end of the day, but it was the management issue. And then, you know, here I am, you know, moving into management consulting and trying, you know, to save the world nowadays. I think, you know, the question, can the satellite mobile network coexist, you know, it's obvious answer that, you know, of course they have to coexist, and it's not the question of if, it's a question of when, and the sooner it happens, the better it is for the end users and for the consumers. I think you know, important role going now forward with the new technologies and startups and disruptors who are changing the landscape, and I'm currently working and supporting, you know, many of those as well, trying to bring, you know, all the years of the experience, but also at the same time just basically trying to merge that. I really see that you know, the old ways of doing things and that behemoths, you know, those elephants, you know, who cannot really change the direction, you know, are actually biggest showstoppers. And you know, you have your entire system, entire machine, like a ship, you know, that goes that direction. But you know, what we're trying to do right now and merging those two worlds, you know, really requires out-of-box thinking, and just, you know, getting everybody in the same room, rather than, you know, trying to prove who is better, rather than trying, you know, to argue, because that's happening a lot, you know, and you know, you have your telecom executives, you know, sitting there and thinking, okay, well, you know, we don't need satellites, we can do everything, you know, with the 5G and build, you know, all those networks, you know. That's, I'm sorry, you know, that's not going to happen. You know, those two worlds have to coexist, and that's the only, you know, way forward here. So that's, I think, you know, in short, you know, my view on that very important question that we're trying to answer.
Thank you, Raphael, and rightly so. I absolutely agree with you. I think elephant was an interesting description of some of our businesses, and I like that. I like the idea of out of the box too, because I think that's the shift we need, and we can come on to this a little bit in a minute. But so Luciana, okay, and welcome GSMA, and welcome as an engineer from GSMA too. As Raphael said, you know, engineers usually just get on and solve things if they're allowed to solve things. And I'm really intrigued about how does GSMA now see its engineering role and space in that sense? You know, how do you see do you see coexistence? Do you see this happening? Or are we still a little bit stuck, perhaps? Anyway, I'll let you go. Luciana, thank you.
Thank you very much, and thank you for the invite to join this panel. It is a pleasure to be here. I just wanted to explain before I get started that I do work for the GSMA. I am an engineer, as you said. In my previous life, I worked in government for many years on spectrum management, and I also consulted for the satellite industry for many years. So I do understand various sides of the arguments that have been made here. They're very familiar to me. And I do believe, and we do believe at the GSMA, that it's possible to coexist, and we should be looking into solutions. Engineers are very good at coming to technical solutions. And I couldn't agree more that there is a political battle going on, and it's very hard to find solutions when there isn't a will to find the solutions. I'm sure we would be able to find them very easily if that was the interest. But we see that the battle, as I said, is much broader than that. Do we coexist? Do mobile and satellite coexist? Yes, we have mobile networks operating today. We have satellite networks operating today. Mobile networks do use satellite backhaul, not as much as maybe the satellite industry wanted, but we can go into the reasons why. But we do have a report that I can share with you about the size, the contribution of the satellite industry into mobile backhaul. And it is very important because we understand that satellite reaches areas where no other technology reaches. So there is a role there. There is a fixed role that I don't think it will be replaced unless, for example, the HAPS technology takes over and is also able to reach certain of those areas. So we do understand that there is a collaboration needed in that front. The difficulty we face is that once we are talking about spectrum usage, we are talking about using the same bands. And when we're talking about using the same bands is where the tension starts. and where no one seems to want to move. So that, I think that's where we get stuck. If we are using one band and satellite is using another band, and everyone is willing to discuss. I was in a panel this week earlier on Sub-Saharan Africa, where the representative from the satellite industry said they want to have an open dialogue in this conference cycle. And I mean the WRC, I've been working with WRCs for 20 years. And that, to me, that's very positive, because in the last 4 cycles I've had, there hasn't been an open dialogue at all. And both sides just don't want to discuss much. So for us, it's very welcoming. We do want to have an open dialogue. We believe coexistence is possible, and we believe we'll be able to find solutions for that. Before I finish, I think it's really important to talk about the role of satellite in 5G and 6G. The ITU has visions for that. The industry has visions for that. 3GPP is working on that. And we believe that it's very positive. In fact, lots of our members do have satellite interests as well. And it's very common for a telecommunications company to have interest in a bunch of technologies. And that is normal and very good. It's not up to us, to the mobile industry, to say that satellite has a role to play in 5G or not. Will the satellite industry deliver their role in 5G? We were not developing technology. We were not doing any integration. That's up to the satellite industry. When I first started working in the industry, we're talking about 3G, and there was a satellite role in 3G that was designed by the ITU. It never really happened. So is that going to be different this time? And I'm really positive that it should be. But again, the onus of doing that is on the satellite industry. We as the mobile industry are carrying on with our plans for 5G, with our plans for 6G. And if satellite does come along and does prove to be an integrated technology that has a very important role to play in both of these technologies, it will be very welcoming to us. Thank you.
Okay, well, thank you, Luciana. Well, you did finish on yeah, will satellite deliver the 5G availability, the 5G connection necessary to make perhaps all our dreams come true? I think is a better way of looking at it at the moment. I do wonder, but we'll leave that for a minute, because luckily our final speaker, James, has probably done something that other people haven't done. And I really like the theory of putting the cell in space, for instance. There's a novelty. Nobody's talked about putting the cell in space, or as we discussed between ourselves, all I hear is backhaul, and more backhaul. Whereas James's company talks about front haul, which is, I find that so exciting because it's just different. So James, perhaps you take us in not so much the product, but the scheme and the thinking and where you're going, because I think this starts to join some of the coexist dots. I think it starts to make a point. James.
Yes, thanks, Martin. Look, absolutely. At Link, we're taking a different approach completely on the problem of satellite and mobile coexisting, and that really approach comes from the ground up, being that why does 90% of the world have no mobile coverage? And yes, you could argue that's a technology issue, but it's also an economic issue, because these are the areas where the population density is so low that there's no economic business case to put down terrestrial mobile towers, provide coverage for people in those areas. So we've taken a different approach and said, well, how can satellite, always known as being very good at doing coverage in remote areas, how can that be utilized in a way by mobile phone users? And the big problem historically with that is that the user is always required to purchase a separate device in order to utilize the satellite service. And that's anything from a backpack to a terminal, to a satellite phone, or even to a sleeve that fits around your existing phone. And so as an emerging satellite operator, our proposition and our rollout is to deliver satellites in space that act as mobile towers orbiting in low Earth orbit, and that they function as a seamless network extension for mobile network operators to allow their customers with their existing phones, smartphones or feature phones, to roam onto the signal provided by those satellites when those users are beyond the existing terrestrial mobile network signal. And that is a different approach to solving the problem of economics in providing coverage for these remote areas. And so we do this in a way that is 100% supportive of deriving new revenues for mobile network operators without them being required to invest in any capex or opex, which is already on the satellite, on our side of being the satellite operator.
Thank you, James. And well, I think it's what you're telling me here, and I want to keep this conversation going about. It's the fact, effectively, your satellite is the cell in the sky. And I've had a great belief that the problem with satellites at the moment, like I think I mentioned earlier, is that they offer a lot of bespoke services. You know, you go on a plane, you have to log on and log into someone's service, which gives you access, not always very good, but gives you satellite internet access. You get off the plane, you get back on another plane, even the same airline, you've got to log on again. It's a separate bill. You probably got to pay for the best. It's a mess because, you know, if you're on the ground with a mobile, and if you're with your system with a cell in the sky and a cell on the ground and all the rest of it, it's you turn the phone on, the mobile operators have set your package up, so you're either allowed so many minutes or pay as you go, or you're allowed the whole 9 yards, everything. But the point is, you just switch the phone on, it locks on, that's it, done, that's it. And people put up with the nuances of maybe the mobile not quite locking on and things not being quite right because they're used to moving the mobile about and getting good service. The satellite industry, it costs more generally, but I think most of it's down to the fact the industry keeps providing proprietary bespoke systems. Nothing's integrated. They can't do billing properly. It's all log on and pay now. It's ridiculous. So my dream, and I think James Link has brought part of that dream to the fore, is that instead of worrying about mobility and the flat panel on, if I hear more about flat panels on cars, I shall scream. That ain't going to happen for a while. It's too expensive, forget it. But what we can do is join cells, or in your case, Link, create cells in space to meet Luciana's ability to extend 5G and make it possible to use it everywhere. Because if you want 5G on a plane, why doesn't the plane become a cell? Simple as that. You just put your phone on, you've either got your air package minutes or you haven't, or you buy them or whatever. But it's all down to you and the mobile operator. Because the panic sets in with the satellite industry, but what do we get? Well, the mobile operator either funds the equipment or part funds it and also gives back money through the whole morass of finance back to the airline. So the airline pockets the profit as well of that call or the internet usage. But if we simply think in cell structure and build the whole of terrestrial space on that basis, guess what? Satellites can join every cell, whether that's a 4G tower, and we need 4G right now as much as 5, because if we cut the 4 off, we don't get the distance. We need a bit of each. 4G is pretty darn good. We need 6, and we need 7 and 8G. But if we connect the cells are fixed on the ground. That makes for cheap operation to satellites, whether they're LEO or GEO or stuck in the middle at MEO. Now, I haven't asked a question there, so it's more, would anybody like to pick up on my rather punchy feelings, a little bit over passionate perhaps, but what do you think, panel? You know, not am I right? I'm not worried about being right, but is that the point? Satellite is all bespoke proprietary when it's got to go cell structure in some way, in the generic way. Over to you.
Well, Martin, I think you raise a very good point with the passenger airline experience. I mean, there is just far too much friction in the way a passenger is forced to go through a series of steps in order to connect to the internet on an aeroplane. They don't have to take those same steps when they're roaming, when they land at the destination in another country. So there's no reason really why it cannot be better integrated. And this is our approach as well, is that we want it to be as frictionless as possible, and that it will just be in the same way that you don't know which mobile phone tower that your phone is connected to, nor should you be really worried about whether your phone is on linked satellite connection or on the terrestrial connection. It's still provided and billed by your mobile operator, of which you are the customer of. And I think that is a far better way to increase customer satisfaction, increase revenues, and build a better working ecosystem between satellite and mobile.
Yeah, I think you're right. I know. I like that. Luciana, do you want to say something? If we appeal to your engineering nature, does that cell type structure? I mean, Link is a specific case, but a cell in the sky is an interesting thing. HAPS is a cell in the sky. I mean, that's already. It's not. I don't get it. It's not a new concept. But do you think by introducing cell and making the mobile operator, I know that the satellite people are going to hate us, but I'm sorry, to make the mobile operator king. They've got the billing, they've got the power. All you're asking for is us to match it with a method to connect into space, so you can use all those wonderful connections as well. It's not just backhaul, it's every darn service in the book that's needed up there. And we have 3 layers of satellite, LEOs, MEOs, and GEOs, all there can do all sorts of jobs and do them well, and get to the underserved in this planet and connect, the other 4 billion that aren't connected. Is this getting, if we got onto that line of thinking, does that start to go along with what you would like to see from the satellite industry?
Yes and no, and I will explain. I think that the idea of a cell in the sky is not new. We have heard that, for example, S-band, people have been talking about that for long periods of time. Solaris and Marsat, lots of companies in the US were supposed to have done that. We actually never saw that happen. I can't tell you how many presentations I saw with people saying you'll be able to connect your mobile phone to the satellite seamless, and I actually never saw that happen. So I think from the consumer perspective, that would be great. I come from Brazil, there are loads of areas without coverage. And I think that I used to use the example of my father, who runs a fishing range. He would love to have connection in his range where he could go fish and use his mobile phone for connection. So that would be great. But then we need to talk about the specifics, and the technical details are really important in that case. So in the proposed by Link on using a base station from the sky, what frequencies are we talking about? So as if I understand correctly, we're talking about frequencies that are currently used by mobile operators, frequencies that are allocated by the International Telecommunications Union to terrestrial services, that are managed by countries, allocated and managed by country to terrestrial services. And how are we going to manage interference? So if you're coming from a satellite, how are you going to go from country A, where you're operating on a frequency that is owned by a satellite operator, and you might have an agreement with a satellite operator to connect to that, to the mobile operator to connect on that country, but once you cross border, are you going to interfere with the satellite, with the mobile operator in the other country? How is that going to be managed? And we've seen that discussion. Lots of governments are actually asking us those questions right now, and we're asking those questions back at them, because how are you going to ensure that our operations, and at the end of the day, the consumers are not interfered with? And I think those questions need to be answered. We're actually quite puzzled on how someone can launch a satellite on a band that is not allocated to satellite services. How does that work regulatory speaking? I'm an engineer, but I work in the regulatory world. And how does that work regulatory speaking? So I think that we have lots of questions. So yes, potentially that could be a really good solution, but we do need to answer all those questions first.
And I think, Luciana, if I can jump in here, you actually given some answers to some of those challenges. So let me go back in time, and when we were building the first 3G networks. And actually, that from the technology point of view, just building the network, you know, as much complex it was, you know, it was quite, you know, straightforward delivery and solving, you know, the challenges. But, you know, after we built, you know, the very first in the world 3G network with Ericsson, I spent another 2 years working on interoperability with connecting with other countries, with other clients. And what you are raising is exactly the same issue. How, you know, we ensure interoperability between, you know, different means and, you know, between the satellite and mobile. And that needs to be regulated, of course. That requires, you know, the brains, everybody getting in one room. And, you know, that was driven at the time, you know, back in late 80s, you know, by ITU. And, you know, there has been, you know, an initiative and conscious effort of everybody that we need to make it to happen, just to make, to the point that Martin made earlier, just to make it simple for the end user. And look at where we are right now. You know, doesn't matter whether you are in Fiji or, you know, at your home or at your summer house. You pick up the phone and you can talk to the entire world, and it's simple as that. And, you know, I think, you know, that simplicity and making it easier for the end user, you know, can only happen if you know, the regulatory part, you know, catches up, you know, with the needs of the end users.
Thank you, Raphael. Yeah, go ahead, Alex.
I want to add one thing, yeah, because sharing spectrum sounds rather simple, but it is not simple, because regulatory for.
While we're, do you want to put a stop there and let Alex start again, Helen, just for the sake?
Thank you, Raphael. I think that's a good point. Regulatory issues is one subject, but sharing spectrum at the end of the day also would require that we agree on certain waveforms. Yeah. Now the waveforms which are in usage on mobile networks are not the waveforms which may be doing good on a satellite. Yeah, simply because of the nonlinear amplifiers on a satellite. Yeah, there is different behaving, so we need to, from a technical side also, we need to see how that can be compensated. This needs additional processing power. Processing power in the satellite, on the satellite, is rather expensive again. But okay, to cut it short, I think we have to look at what's going on in the 3GPP, because there exactly the attempt is done to bring together on an engineering level these two worlds. Yeah, and why is it done? Because in principle there is the full understanding in the telecom industry, also in the terrestrial one, that the service quality, the data demand would need all sources that are available, and this includes satellite. This includes free space optics and so on. And we were not even talking about optical networks or certain quantum key distribution that may be coming on top of that. Yeah, I think there had been a start. Yeah, if the VSAT or the SATCOM industry of today is ready to join that, yeah, or if they still will build their own ASICs to protect their market segment. Maybe these are different market segments. Yeah, not one size fits all. Yeah, you have to see satellite communication by definition is always a niche market. However big that network may be, it is a niche market compared to the data and voice minutes going over terrestrial networks. And personally, I would not surprise if we would see two parallel scenarios, or even three, with flying cells. Yeah, they may go straight forward with standards coming out of 3GPP, but there is also a lot of demand still for networks which may be more proprietary. Yeah, proprietary has also an advantage when it comes to be secure. And that is the next thing. Sharing spectrum, sharing waveforms makes you rather vulnerable also on the security side. So also their answers need to be there in the long term.
Well, I'm going to stop us there because time is getting tight now for this recording. First of all, thank you, because you've just about raised every single, I don't know, I didn't say this was going to be simple. Let's put it like this. We're all aware this is not simple. Luciana, Raphael, Alexander, you did some good stuff. But I do see, you know, we say niche, and I think James is looking at less niche, more just out there. I just see, we're already seeing these differences, but I think you're right, Alexander, about, you know, there will be different verticals, and there may be, you know, common verticals, 3 main verticals, some of it proprietary, some of it open. It's all going to happen, but we are not seen as an industry doing it. You know, ask Luciana, she sees we're not doing it. We're not getting to grips with it. I keep hearing about 3GPP. People ram it down my throat all the time. I see very slow progress when the users are wanting it now. They already think it just works when they go on a plane or a ship. They expect it. And we are way behind the thinking. And what I'd like to conclude here, I'd like to take an action away here. I want to continue this conversation, and I want all the parties in on this because, and thank you, Luciana, for raising that word. The word we don't often raise because the rest of the world gets in such a touch over it, but interference, managing spectrum, that is something key to make everything work well. We manage that, everything else falls into place. Think about it, if we didn't have to worry about allocating frequencies for them and us and someone else, think if we had a super network, which I believe we do, but we actually controlled that using, you know, AI, machine learning, technology, software definition, it's all there. Imagine being able to allocate the frequencies you needed to make the service happen dynamically. You don't need a lot of ITU these days. You need some, you need disaster recovery, you need safety bands, you need some frequencies left to do certain jobs, both on the ground and in the air. But you know what? We don't even know how much we use. Does anybody actually know how much of their spectrum we use? I'm just raising questions. Let's not answer them. Think about it. We know very little about the thing we keep arguing about. It's time we engineered our way out of this crazy 4-year cycle of allocating spectrum. Spectrum is there to be used. It's there for all, and we should be clever enough to manage it better. My conclusion is that to answer all the questions, it's the management of spectrum is right up there first, so that all these services can work. And it doesn't matter, just ignore the worry about proprietary and bespokes or whatever. It's all got to work together, but we need, the satellite industry needs to look at the mobile industry, and I still think the mobile industry, that's where the money is. They're king in this. They have the processes. So stop reinventing wheels, go with the process we know that work. And everybody likes using their mobile phone, and that's marvelous. So let's stick with it. So on that note, thank you so much. I hope you all can join us at our next workshop or workshops next year. If we're allowed to do such things, we'll try. But I'm thinking, Helen, for Helen Whedon, our leader, we need to carry this conversation on, because now the previous panel was dealing with spectrum. So is it the chicken and the egg? Which panel should have come first? I don't know, but I thank you all for being here, because you just completed a big story. I know we haven't resolved it, but I think we're getting to the bottom of where we need to start, especially in the satellite industry. Thank you again. Great fun, but with a serious point. So satellite industry, watch this space. You need to.